Welcome everyone, and thank you for joining us today. Just a couple of webinar logistics. It might be easier for everyone to hold questions until the end, but if you do have a clarifying question, please feel free to jump in. My name is Melissa Foley, and I'm a marine ecologist, and joining me today to present the webinar are Ashley Erickson and Aaron Praler, who are both lawyers. And we are all early career fellows at the Center for Ocean Solutions, a collaboration among Stanford University and Hopkins Marine Station, the Monterey Bay Aquarium, and the Monterey Bay Aquarium's Research Institute. For those of you who don't know us and our work, our mission is to bring the natural, social, and physical sciences to bear on the challenges facing the ocean. Importantly, we are a non-advocacy organization that works with a variety of partners to achieve our mission. The purpose of this webinar is to introduce you to the Ecological Principles Guide, which we hope many of you have already received in hard copy at your offices. The primary audience for the guide is California State Agency staff, but the information in the guide is highly relevant to what many of you do on a daily basis as members of the conservation NGO community. The guide provides insight on the interplay between science, management, and policy, and the importance of translating science into meaningful, usable management scenarios. We hope you find the guide relevant and useful in your work as environmental advocates. We are going to try to cover a lot in the next 40 minutes so that we have plenty of time for questions and discussions at the end. So I will start with an introduction to the guide and how it was created. Erin will then take over to talk about the ecological principles which form the backbone of our analysis in the guide. And she will then discuss how these principles can be applied to agency decisions through a series of case studies. Ashley will focus on some overarching themes in management found in the final chapter of the guide and tell you about some of our efforts to date to distribute the guide. Finally, we realize that the guide only explores 4 California state agencies, so I will walk through an example of how the principles are applicable to other state agency decisions to emphasize the guide's general applicability. To start us off, a little history about how we got to this point. The creation of this guide has been a long-term project that has involved scientists and agency staff from the beginning. In 2009, we interviewed agency staff to better understand how science is used in daily decision-making. We also convened a group of ecologists to identify and distill 4 ecological principles important for planning and management. In 2010, those attributes were published in peer-reviewed literature, which we then returned to the agencies with to discuss. Agency staff's primary response was great, but how do we do this? So in 2011, we started working with agency staff to determine how these principles could be incorporated into decision-making frameworks. The results of those conversations are reflected in the guide. Finally, as you know, the guide is now printed and available, and we are going back to the agencies to make sure they have access to the best available science that supports their existing regulatory authorities. And of course, we are also reaching out to our secondary audiences, such as yourselves, to introduce the guide. So what exactly is in the guide and what does it do? First, it translates peer-reviewed science for agency staff and a variety of secondary audiences into relevant, digestible information. Second, it illustrates how the ecological principles can be applied in daily decision-making processes using existing authorities. And finally, it provides a one-stop shop of information that applies across many agencies and decision contexts, including challenging issues such as cumulative impacts and interagency communication.
I'll begin by introducing some key concepts, ecosystem-based management and the ecological principles introduced in the guide. Historically, as many of you know, our coastal and ocean management actions have typically revolved around a single sector. They've treated humans as external to the ecosystem, often optimized short-term yields over longer-term benefits, and relied on market-based pricing to drive extraction rates. Although management practices have been conducted in this fashion for centuries, it is clear that this style of management may not be facilitating resilience of the system or long-term sustainability for the ecosystem or the economy. Over the last 2 decades, ecosystem-based management has been identified as an alternative to business as usual. EBM differs from traditional management in that it considers whole ecosystems and brings humans inside the ecosystem. It also focuses on the long-term sustainability of ecosystem goods and services, such as food, clean water, and coastal protection. We all think this sounds great, of course, but many of us have been working on how to actually do EBM. We all realize that EBM is still a really big concept without an instruction manual. So in the guide, we've tried to break EBM into more digestible pieces by focusing on the ecological principles. Now, a little bit about the principles that we focus on within the guide. The first principle is to maintain native species diversity. Diversity can be measured in a number of different ways, including abundance, richness, genetic, or functional redundancy. Diverse ecosystems tend to have higher rates of productivity, are less vulnerable, and they're more resilient to disturbances. Habitat diversity is the second principle. Habitat diversity and heterogeneity are represented by the types and arrangement of fixed habitats as well as dynamic ones, such as upwelling areas or breeding aggregations. Habitat diversity and heterogeneity are important for supporting high levels of diversity and productivity, connectivity between populations and life stages, and providing shelter. The third principle is to maintain populations of key species. These include keystone species such as otters, foundation species such as kelp forests or seagrass beds, top predators, and basal prey. Key species help to maintain diversity, stability, and resilience of the ecosystem, and may serve as ecosystem engineers, providing habitat that would otherwise not exist. The final principle is to maintain connectivity between populations. Connectivity is important for population persistence via the movement of individuals through time and space, and for maintaining the flow of subsidies, such as food and nutrients, across ocean ecosystems. Connectivity is important for supporting diversity, ecosystem resilience, and the ability for systems to rebound after disturbances. The second set of concepts we cover in the guide fall under the heading of ecosystem vulnerability. While the ecological principles represent the important attributes of a system, a management plan could still fall short if it fails to consider the vulnerability of the system. There are two big aspects of vulnerability to consider. The first is cumulative impacts. There are an increasing number of activities occurring in and on the ocean that have an impact on the ecosystem, including land-based, such as nutrient runoff and coastal development, ocean-based, such as fishing and shipping, and climate stressors, such as increasing temperatures and ocean acidification. It is increasingly being recognized that the overall impact of multiple activities co-occurring in space and time are having a detrimental effect on our coasts and oceans. We'll talk in more detail about cumulative impacts later in the webinar. The second set of ecosystem vulnerability is climate change, including sea level rise, temperature increase, ocean acidification, and inundation. These changes pose very real threats for marine ecosystems. From a planning and management standpoint, it is important to know if there are areas that are resistant to climate impacts, how species distributions might change in the face of climate change, and how key habitat for species may be affected. The guide helps to break all these principles down into smaller actions, which may be useful as you think about the agency decisions you are working on and advocating for. For each principle and vulnerability concept, the guide provides a checklist that helps agency staff incorporate the principles into their decision-making process. As we've introduced the guide, we found that people really gravitate towards these checklists. They're just another digestible way of thinking through applying the principles. So in addition to providing an in-depth explanation of the principles and why they are important to management, the guide also walks through 3 case studies for 4 different state agencies: the Department of Fish and Game and Fish and Game Commission, the State Lands Commission, and the California Coastal Commission. We'll only briefly touch on the Department of Fish and Game Commission and the State Lands Commission chapters in this webinar, but we will spend some time on the Coastal Commission example for you today. We used a number of different selection criteria for the case studies. A few of these included the decision had to have been made in the last 10 years, the case study had to span the geography of the California coast, and they had to characterize a typical decision for that agency. We realized that selecting only one case study for each agency by no means covers all of that agency's decision-making approaches, but it does provide a small window into how they are thinking about the resources they are responsible for. Finally, we use the case studies as an opportunity to explore how the ecological principles were already being used by the agencies and highlighted areas where they could be better incorporated. For the Department of Fish and Game and the Fish and Game Commission, we focused on the Marine Life Management Act, which is chock full of great EBM language, including the requirements of fishery management plans, and strongly encourages a science-based approach. We used the White Sea Bass Fishery Management Plan to identify where the department did a good job accounting for the 4 ecological principles and where its application could have been improved. The Marine Life Management Act identifies 7 primary objectives that all fishery management plans should achieve. These include sustainability, ecosystem-based management, habitat conservation, limiting bycatch, restoration, fishing communities, and non-consumptive values. All 7 of these objectives are consistent with some or all of the ecological principles. For the State Lands Commission, we looked at the Public Trust Doctrine and the California Environmental Quality Act as the agency's enabling authorities. We walked through the Public Trust Doctrine and supporting case law, as well as the CEQA process, its checklists and guidelines, to tease out the principles. We applied this analysis to a fiber optic cable lease off of Morro Bay as our case study. The CEQA environmental checklist form poses a series of questions about a variety of environmental factors, such as biological resources, hydrology and water quality, noise and air quality, to highlight potential impacts. Like the objectives in the Marine Life Management Act, the series of questions posed in the CEQA environmental checklist form are consistent with all of the ecological principles. For the California Coastal Commission, we focused on the California Coastal Act. And I'll use the California Coastal Commission case study to provide a more in-depth description of how we analyze the case studies for each agency in the guide. This table matches language found within the Coastal Act that is consistent with the ecological principles. We view this as our Show Your Work section, where we compared the agency's enabling authorities to the ecological principles and identified where the current law reflects these principles. As I just mentioned, with the Department of Fish and Game and the Marine Life Management Act, we had a very similar table. And for the State Lands Commission, we created a similar table matching the CEQA environmental checklist form to the ecological principles. So for the Coastal Commission, we selected a dredge disposal permit as our case study. In 2005, the Coastal Commission reviewed a permit from the City of Eureka to dispose of approximately 80,000 cubic yards of dredge material taken from 10 locations along the Eureka waterfront. A coastal development permit was required for disposal of the dredge material. The proposed disposal site was in the nearshore ocean close to the Samoa Peninsula. This disposal site, located in the surf zone, had been used 3 times since 1977, with a cumulative disposal of nearly 2.2 million cubic yards. In addition, a dredge project at Woodley Island Marine Boat Basin nearby was also permitted to use the Samoa Peninsula nearshore disposal site to dispose of an additional 158,000 cubic yards of dredged material during the same time period. We reviewed the staff report for the Coastal Development Permit to look at how the Coastal Commission used their jurisdiction under the Coastal Act to consider and account for the ecological principles and ways that the Commission could think about accounting for them in future projects, while still remaining consistent with their existing laws and policies. The Coastal Commission accounted for native species diversity in its coastal development permit by requiring a 3-year monitoring program to monitor species composition and abundance of intertidal invertebrates in areas directly affected by the dredge material disposal. They also required the City of Eureka to monitor a control site. We felt that the Coastal Commission could have taken the monitoring program one step further by providing guidance for measuring specific ecosystem attributes. If the Coastal Commission required a before-after control impact monitoring design, they could have established a proper pre-project baseline of species diversity. That baseline is important for monitoring the recovery of the ecosystem following the impact of a specific project. Undertaking the recovery from a pre-project baseline could also be used to require additional or alternative mitigation measures from future similar projects. The Coastal Commission adopted a similar approach to accounting for habitat diversity and heterogeneity by using data from previous monitoring efforts to conclude there would be no long-term significant impact to surf zone habitat. We recommended identifying and measuring indicators before, during, and after development activities to understand whether previous estimates or thresholds are being met or exceeded in real time. In thinking about key species, the Coastal Commission analysis focused on eelgrass. Moving forward, we recommended continued focus on the effects of proposed projects to key species by assessing impacts to eelgrass habitat, fish spawning habitat, and juvenile fish populations. Population reductions or loss of key species can have system-wide cascading effects because of key species' influence on food web dynamics. The Coastal Act provides a tool for protecting important marine habitats in its environmentally sensitive habitat areas, also known as ESHA. Section 30240 of the Coastal Act protects environmentally sensitive habitat areas against any significant disruption of habitat values and significantly limits uses of those resources and development in adjacent areas. While ESHA has been used only infrequently in the marine environment, it has been used in the past to protect eelgrass habitat, and it could provide an important tool for protecting sensitive key marine species in the future. Finally, looking at maintaining connectivity of populations, the Coastal Commission considered impacts of connectivity of eelgrass patches. They concluded that even though patches of eelgrass would be disturbed by the dredge pipeline, there was sufficient eelgrass in adjacent areas to recolonize the pipeline route after the project finished. Moving forward, we recommended that to think more broadly about accounting for connectivity, the Commission could use wind, current, and wave data from SENCUS to better understand ocean circulation patterns relevant to assessing project impacts on sensitive biological communities. Understanding how ocean circulation patterns will affect the transport of sediment provides insight to the potential impacts to the biological communities in the area, as well as whether there is a better time of year to undertake such a disposal project. By understanding a project's impacts on the mechanisms of connectivity, we can ensure that permitted activities are consistent with maintaining or increasing the connectivity of the ecosystem.
All right, moving right along in our outline, the final chapter of the guide discusses overarching themes in management. We threw a little bit of everything into this chapter, and we often point to it in our meetings with agency staff to emphasize the transferability and general applicability of these concepts across the full management spectrum. Specifically, this chapter touches on a variety of overarching issues that managers grapple with on a daily basis. First, interagency communication. As many of you know, development projects along the coast often require multiple permits from multiple agencies. Clear communication between agencies early on regarding what they each will require of the applicant helps streamline the decision-making process. Frequent communications also help agencies share expertise and analyses and discover and share public concerns about the project. Second, the guide emphasizes the importance of accounting for uncertainty, namely scientific uncertainty and the value of taking a precautionary approach when making management decisions. Next, context. Here, the guide reviews the common mismatch between agency jurisdictions and the scales of ecological processes and discusses the importance of taking this into account. Fourth, cumulative impacts analysis. Here, the guide reviews the scientific approach to cumulative impacts analysis and compares that to legal and policy approaches. I'll talk in more detail about this in just a few slides. Fifth, we review the agency difficulties around monitoring and mitigation strategies. Specifically, we emphasize that monitoring programs instituted by an agency are only as good as the data collected and the data analyses following that collection. Finally, we briefly discuss adaptive management and the value in doing it right. As many of you know, adaptive management is one of those things that sounds great on paper, but in practice is extremely difficult. But a flexible management approach is absolutely necessary to incorporate new information and lessons learned from past management decisions into new management approaches. All of the overarching themes we've identified in the guide have a big impact on management decision-making processes, but in our discussions with managers, we've found that accounting for scientific uncertainty, especially in the face of climate change, and conducting cumulative impacts analyses have garnered the most attention. So I'm going to touch on these two specifically here. First, climate change presents a considerable source of uncertainty to agency staff and resource managers.
There are a number of strategies that agencies can use to either reduce uncertainty or build in adaptive mechanisms to prepare for eventual changes. One way of preparing for uncertainty is to adopt an insurance policy type approach. By protecting redundant species and habitats, we can improve the chances that our marine resources will be resilient and able to adapt to climate impacts. But there are still major gaps in our understanding of the potential risks, and we are only beginning to understand how the cumulative effects of multiple climate stressors will combine. Focusing our attention on both mitigation and adaptation strategies should be a priority. As I just mentioned, accounting for cumulative impacts is a big challenge for agencies. Part of the issue at hand is the different ways that science and the law treat the subject. Because these differences continue to come up in our analysis, we decided to unpack them in detail in the guide. First, the scientific approach. Scientists define cumulative impacts to include the temporal and spatial accumulation of impacts that cause environmental change, whether they are impacts from an individual activity or from multiple activities. In practice, this definition tends to be all-encompassing. We want to know all direct and all indirect impacts from all types of stressors over appropriate scales of space and time. This approach requires, as you can imagine, a lot of scientific data and also a lot of analysis to correctly assess cumulative impacts. One of the biggest hurdles is choosing the correct baseline from which to measure all additional impacts. The scientific approach is to use a historic baseline. In other words, measure the accumulation of impacts based on a past condition. This condition, of course, may not be pristine, but oftentimes it is in a set place and time that could be attainable. This all sounds pretty good until you analyze California's laws and policies behind how the agencies should undertake cumulative impacts analyses. So over here on the right, we've got the legal and policy approach. First, the definition, as you can see, is very different. For starters, it shouldn't surprise any of us that the lawyers got to it, and it's ridiculously long and complicated. I won't read this to you, but I do want to draw your attention to the portion that reads, to other closely related past, present, and reasonably foreseeable future projects. This closely related language that you see here in this red box is what makes this definition of cumulative impacts significantly different from the scientific definition. Whereas the scientific definition looks at all impacts, the legal definition requires only those impacts from closely related past, present, and reasonably foreseeable future projects to be considered when doing the analysis. In practice, this means that the analyses tend to be sector-specific. For example, a cumulative impacts analysis for a desalination plant may only review other desal plants as related projects and ignore other impacts in the local marine environment, like those from fishing or stormwater pipes. I'll just talk about one final difference here, and it is perhaps one of the largest. The case law surrounding cumulative impacts analysis has established a bright line rule that when undertaking the analysis, agencies are to use a baseline of today, and in some cases, which I won't go into in today's webinar, a baseline in the future. This means that all past projects and impacts are folded into the current baseline, and the agency must only look at the impacts of the current project and any foreseeable future projects to determine whether their cumulative impacts are significant. As you probably realize, this means that the threshold of significance is much, much higher than it would be if the law required a historic line. In other words, using a baseline of today makes it much easier to find no significant environmental impact. So I'll stop there, though as you can imagine there is a lot more to say here and quite a bit more to read in the guide. But to summarize, the scientists do it different than what the law requires. It is difficult to conduct an analysis that incorporates multiple types of activities that have like effects but are outside of the particular sector being permitted. And finally, there are major legal limitations to defining the baseline as anything but present conditions. So, To sum up the overarching theme section, we just wanted to mention that we also created checklists and undertook analyses for addressing climate change and cumulative impacts in the guide. While we didn't walk through these examples in our deep dive of the Coastal Commission case study today, we wanted to mention that the guide does a similar analysis for climate change and cumulative impacts in each of the agency case studies. Moving along in our outline, we thought you might be interested to hear about our process for rolling out the guide and how we've been introducing it to agency staff and other interested audiences. So, among other things, we've had multiple meetings with the directors of the Department of Fish and Game, the Fish and Game Commission, the State Lands Commission, and the Coastal Commission, and all relevant staff regarding the guide's contents. We've started discussions with some of these agencies on conducting teach-ins and workshops with staff. We've started to present on the guide in front of agency commissions and at committee meetings. We've gotten over 300 hard copies of the guide out the door to date to all agency contacts, interested academic institutions, and of course, environmental NGOs like you. And finally, we've started to develop a web tool that matches the checklists in the guide to available data and resources in California. So briefly, just to give you a little flavor of some of the aspects of the guide's rollout, I'm going to talk about these two bullets. First, agency, commission, and committee meetings. After a meeting with the Department of Fish and Game's Program Manager for State Marine Managed Species, Tom Barnes, as well as the department's director, Chuck Bonham, about the guide, they invited our team to present the guide in front of the Lobster Advisory Committee, who is helping the Department of Fish and Game develop a spiny lobster fishery management plan, as many of you may be familiar with. Just last week, my colleagues Melissa and Aaron presented the guide and its analysis of the ecological principles and the MLMA to the Lobster Advisory Committee. We are also currently developing an online tool that will work as an extension of the guide. This tool is intended to further assist agency staff with incorporating the items in the checklist into their analyses. We are working with the Ocean Science Trust to connect each item in the checklist to data that it is or will be made publicly available through California's Marine Geoportal. So what does this look like? Here, as you can see on the left, we have the connectivity checklist. This third item on the checklist states, identify important larval retention areas. And many of you may recognize the picture in this slide showing the bathymetry of Monterey Bay. This is relevant to the connectivity checklist because this is the type of spatial data that can help identify potential areas for larval retention, but also help to identify types of habitats that may be present in the area. So, of course, we don't have all the data, so where data are not available to support a checklist item, we will summarize scientific literature that supports the importance of considering the checklist items in the analysis. So for example, these bullets here citing Roberts and McKelly are their literature references to why the connectivity principle is important and in what context. The idea behind providing this information is that for some of the items in the checklist there will be no data, but there may be some general take-home messages that we can extract from the literature that will help to back up the agencies if they use something like larval retention area as a reason for necessary project mitigation.
Because of time constraints, we were not able to include every California state agency with responsibility over ocean and coastal resources in the guide. However, we think that the checklist, as well as the lessons drawn from the case studies we did review, are more generally applicable to other state agencies and decision context. So I want to quickly walk through one of our checklists to show how it can be applied to the state's MS4 stormwater discharge permit process to demonstrate to those of you who are working on other issues or with other agencies how the checklist and the guide could be applied to other contexts. And we are by no means experts in water quality management or the State Water Resources Control Board or Regional Water Quality Control Board's decision-making processes. So we chose the native species diversity checklist to demonstrate this generality of the principles and checklists, but any of them are transferable. So the first checklist item for species diversity is to identify the number and types of species impacted. For stormwater, this might include looking at things like fish, algae, and vertebrates in the water column and on the bottom of the ocean that may be affected by the discharge, particularly if there are economically or ecologically important species present. The second item is to identify the number and types of impacts. Stormwater discharge may consist of multiple types of impacts, such as fertilizers, which is a nutrient impact, natural debris, trash, and pesticides that can differentially affect species and habitats. The next item is to map and analyze the spatial distribution of impacts. So really focusing on the zone of influence, or how far that stormwater plume spreads and how that overlaps with the spatial distribution of species. Another item to evaluate is the duration and frequency of the impact. So when does runoff occur? How long does it last? As well as any seasonal characteristics of runoff. So does it have different qualities in the fall versus the spring, during first flush, or late season storm events? And finally, identify any important life history stages, such as larvae or breeding aggregations, that may be affected by the impact. So we could go through the other 5 checklists as well and do a similar analysis to determine how the items in the checklist apply specifically to agency decisions for stormwater discharge. So to wrap up, we wanted to leave you with a few concluding thoughts. First, ecosystem-based management is difficult, but new tools and approaches are being developed that make this approach more tractable. Second, translating science for management is difficult, but necessary, and doing the hard work means that science can be applied today. And finally, the ecological principles highlighted in the guide are highly transferable regardless of the decision-making context. So we just wanted to thank you again for joining us today. And if any of you need more hard copies of the guide or questions that we didn't answer today, please let us know.